American Railway Signal Principal Practices, Chapter 21, Hump Yard System, and 1948. Association American Railroad Signal Section. All right, Chapter 21, Hump Yard Systems. The Signal Section of Association American Railroad defines hump yards as follows. Hump, the portion of the hump yard that contains the summit over which cars are pushed and beyond which they run gravity. Yard hump. A yard is which the classification of a yard is accomplished by pushing them over a summit beyond which they run by gravity. Generally, in early days, railroading freight car was not classified except for picking them up and delivering them some sidings various points on the line. A traffic increase yards were built and freight cars were classified by flat. Switching is still done where the flat traffic density is light. Next hump, the gravity yards were built with the gravity would do a large part of the work formerly done by the switch engine. The application of the power operated with the switch controlled from the center point as well. When the instituted the latest improvement of the affecting economies in the car, the retarder system, power operated switch systems. The first installation of a power operated switch in a hump yard was made in Pennsylvania Railroad in 1891 with the Altoona, Pennsylvania. Later, the hump yard were equipped with a power-operated switch on Baltimore and Ohio, Central Georgia, Chesapeake and Ohio, Chicago, Western Indiana, Illinois, Central Missouri, Kansas, Texas, Missouri Pacific, and New York Central. All right, this shows your push-button machine. Figure 2 shows a circuit of a single controlled switch with a push-button machine with the battery, the ground, the current, the going from the length of the rail, a positive negative display of relays and parallel circuits with a push-button machine switch. All right, New York, New Haven, Hanford, Pennsylvania Reading, and Richmond, Fredericksburg, Potomac, and the Union Railroad. Since the invention of the car retarded, the hump yards have been equipped with a power-operated switch, but not with car retarders. But in the case of switch machine signals and control machine circuits have been followed with the practice of the car retarder installation. The usual operation involved with providing with the operator with the scheduled movement required to classify the cars. Here, he is then able to follow with the movement of the different cars' successive operations track indicators. Electro-pneumatic. The push-button machine illustrated in Figure 1 similarly to the install of the 1891 upper row buttons of the term with the normal. The lower row is the reverse. The pressing of the normal button of the machine forces out of the to the corresponding reverse out of the corresponding reverse button, vice versa. Two buttons relating to the switch are joined by the back of the front board and walking beam or contact of arm, which is pivoted in the center. The indicators above the buttons are controlled with the track circuit. The track circuit is unoccupied. The position of the switch is indicated with the track circuit is occupied with the indicator takes the mid position in which the position is locking. Dogs engage with the locking bar with the position of the button. Hence, the switch cannot be changed until the track circuit is unoccupied. Figure 2 illustrates the circuit as of the control switch, signal switch. The switch cylinders valves are similar to those used in the control switch and electro-pneumatic interlocking installation described under the heading of the power switch machines. The push button electrically connected with respectively with the switch valve magnets and push buttoning in the upper and normal row in which switch assumes the normal position, pushing the lower and reverse button with the switch assumes the reverse position. Electric. The lever machine with the control switches consists of the cabinet with the vertical panel through the lever project. The upper position of the figure 5.3 shows the machine of electric the machine lever on electric switches. This was on the side. All right. This is note your single control switch. Control from the lever machine. Note the context A for the completion of the stroke, reverse to normal, B the open, and B A it's open, normal to reverse, B closed, B open, reverse to normal, C closed when the switch is closed, normal, reverse, C is open, D is closed, and D is open normally. E is closed, switch unlocked for the reverse position. E open, locks up the reverse. F closed, unlocks the normal portion. And F open, locks up the normal. Alright, that's a drawing of a single switch control lever machine. I'm not really good with these older 1948 electrical drawings. The lever is normal and the lower position is reversed, indicating with the light show the position of the switch occupancy of the track circuit. Figure 3 illustrates a lever of this type. Figure 4 illustrates the control circuit with the switch operated within this type of the control machine. The relay built is each other lever that connected with the control circuit with the switch machine is to ensure the completion of the movement of the switch once it has been started. The track circuits were occupied with to prevent operation of switches. Model 6 switch machines are used with operating switches. These type of machines are similar, illustrated in Figure 35, with only the difference beginning with the electrical pole charge is used to permit the traversal of the mid-stroke. Alright, your car retarder system. Prior to the use of the car retarders, many freight yards present with the classification of cars handled over the humps when they ride over the cars are used by handbrakes to control their speed. The switchmen throw the switch to set up the proper routes and place skates on the rails to stop the cars and properly retard the handbrakes. The cost of so much operation is expensive, principally because of the large number of the men involved with the necessity of returning the riders to the hump yard and waiting with the engine's riders to return. In many cases, the riders walk back, but a large yard, they ride back on motor cars. The greatest lost time is either due by the engine waiting for the riders waiting for the cars, the arrival train into most yards, and such a large number of the cars must be handled in a short time. The leaving of the period in when work is slack is difficult to provide the proper balance between the motive and the power and the riders, which balance is essential in order to obtain the maximum efficiency. The car retarder provides the handling of the cars with the hump yard using the minimum number of the men engines and provided with the ample capacity of the handling peak periods of the traffic without delays and attendant with the calling out additional riders and switchmen. Alright, the system includes the following devices: a car retarder to control the speed of the cars from the crest of the hump for the classification of the track, the switch machines throwing the switch to select the proper route, skate machines placing with the skate on the rail to stop the cars which have not been properly retarded, control machines for the controlling of the above units, power plant converting with the main source of the powering into the power for the proper type where it may air, direct, and alternate current, single system for the controlling of the movement of the trains and to and over the hump movement of the engine through the switching area, communication system with the transmitting of cars from the yard office of the hump office and individual towers with the verbal communication between the hump master and the operators, between the hump master engineer man and the pusher and the trimmer engines, floodlights provided with the proper illumination, night operation, hot oil plant, lubricating journals in the winter provided with the easier rolling cars. Historical in September 1923, Mr. George Hanover, the vice president, and Mr. E.M. Wilcox, master car builder, Indian Harbor Belt Railroad, invented, installed, and tested two 40-foot sections of retarders, now known as the Hanover retarder. The portion of the New York Central Railroad operated with the Indian Harbor Belt Railroad, Gibson, Indiana. This result was so satisfactory that it produced install additional units for the end of December 1924. When the yard was complete with equipped with the patents were taken with the by the masters and Hanover Wilcox covering the type of the retarder they found successful, since they may be different types that have been tested here and abroad using various kinds of power operation. These types are electropneumatic, electrical, mechanic, and hydraulic. In America, the electropneumatic and electric types prevail, whereas in Great Britain and the continent, where condition relative as design of rolling stock wheel tolerance method of operation difference in the hydraulic been used more extensive. Track layout and grade outs. It is more important that the track layout and grade outs is designed with the retarders located properly, since they affect the efficiency. First off, for the installation, the retarders were first installed with the minimum of the track change with considerable desirable. Consequently, the only changes were to cut out every other track in the adjacent track instead of the ladder installed with retarders at the point of the ladder, as well as the hump lead and on each of the classification trucks. The East St. Louis yard on the Illinois Central Railroad, figure 5, is of this type. As the art developed, it seemed advisable to make more track changes with the install with the fewer retarded. Therefore, the reconstruction of the Mechanicville yard of the Mechanicville, New York, and the Boston Main Railroad, figure 6, with the tracks were brought together in the group sizes of 6 each, and then connected with the shortest possible distance, with the hump lead and retarder being used in advance of each of the group, as well as the sub leads and hump lead. The design of the yard is still being used. The two of the latest installations are is illustrated in Figure 7 and 8. Another variation consists of the intermediate retarder with the sublead shortening the distance between the crest and the clearance point, together with the revision gradients of the degree with the change, the arrangement of the fourth lower hump yard with less retarders, the good operations such as the track layout in Figure 9. Where ultimately the humping capacity is not required, as many of the 9 tracks have been included in one group, which has a few has 2 groups per yard. The average gradient of the crest of the hump that usually is sufficient to cause the slowing of the rolling car to move the crest into any of the classification yard tracks under advisory weather conditions. Retarders are installed in intervals to permit the controlling of the speed of the heavy and fast rolling car so that it will not enter the classification tracks at high speed. The gradient and classification track usually designed so that the heavy and fastest rolling car will not accelerate to speeds which are excessive maximum permissible coupling speed. Alright, this shows the East Illinois, St. Louis yard of the Illinois Central Railroad. The powerhouse, the scales, the office, your track gradients. And then like 1 through 26 different tracks that I'm grouping in the... This shows the repair yard, the hump signal crest to the hump, and the transfer yard while it goes down the hill to the office. Mechanical yard, Boston, Maine, and Railroad. Figure 7 shows the Stanley Yard, New York Central yard lines. Figure 8 shows eastward Willis, Galesburg, Illinois, Chicago, Burlington, Quincy Railroad. And then Figure 9 shows the D-course yard of the Louisville, Nashville Railroad. Figure 10 shows the Portsmouth Time Freighting Yard, Norfolk Western Railway. The ideal arrangement of the track layout gradients with retard and such of the time required for the handling of the car, the crest for the clearance point of the classification track, and the same with each car, regardless of its weight of the rolling condition, which means the lightweight and slow rolling car will move approximately the same speed as the heavy, the fast rolling car, with the retarder, but not necessarily released from the last retarder. Such operation provided with an even space of the cars, which allows the ample time for the operation switches between the cars and ensure the maximum humping capacity. Track circuits and protection against the operation and switch under the cars which were not used in the earlier installation, since this was believed that it would slow the operation. Design of the most recent track layouts and gradients was found with the track circuits could be used an advantage with the running of the cars with the high speed provided with the sufficient spacing with the operation switch between the cars. The use of the track circuits has resulted in the economy of the preventing damage of the car's contents, as well as roadway equipment, eliminating derailments due to the switches being operated between the trucks. Car retarders. General principle. Retarders insecure, but they apply with the pressure to the shoes which contact with the inside and outside face of the car wheel that provided with the friction which opposes the turning of the wheel. The pressure is cushioned by these springs and some other means. Figure 11 shows the eastward Annuals Yard, Pennsylvania Railroad. This shows the eastward yard, Clearing Railroad, Beltwood Railroad, Chicago. Retardation is obtained with the proper proportion with the pressure applied with the coefficient friction, the height of the contact between the shoe and the wheel, and the length of the retarder. The means are provided with the varying amount of the pressure as to vary with the degree of the retardation allows it also move to the shoes into the opening position, thus allowing the cars to run free without retardation. Smooth retarding considered important for the retarders in the Great Britain and on the continent, since the cars being handled with lightweight and more easily retarded. Therefore, the hard retardation is too severe for the contents of the car might be shifted and cause damage. In America, the ratio of retardation to the weight of the car is much lower than therefore there is practically no possibility of shifting the contents of the car, since the height of the shoe bears against the wheel and lower is the chance of lifting the car if too much of the pressure is applied. When the car is lifted with the derailment may occur, the equalized shoe pressure is used generally so that the maximum average pressure can be secured without having pressures per wheel in excess of which the wheels will lift. This is a variation of spacing the wheels on the axles as well as thickness of the wheels. Therefore, equalized shoe pressure is an advantage with the compensation of the variation of the force throughout the retarder are self-contained, with the design usually such that the parts will adjust with the compensation for uneven surfacing, adjusting, provided with the compensation aware of the shoes and the bearings. And with the most recent installation, the retarders are mounted with ties set in a concrete foundation. In some cases, directly on the concrete. In the case the ties do not need to be tamped, the construction is sufficiently strong to withstand heavy shock. Provisions are made with the design so that the ties can be tamped. The types of retarders. Two general types of retarders have developed and installed with the American. One of the electric uses electricity both to control and operate, while the other is electropneumatic, which uses electricity for the control and compressed air for the operation. Provided with the four-step retardation as well as the open and free position, they are usually used as follows: one, open position, no retardation; first position, empty cars; second position, light loads; third position, medium loads; and fourth position, heavy loads. The open and free position permits and restricted movements of the locomotive over the retarder. The electric retarder type A, the figure this type of the figure 13 was first installed with the east of the St. Louis, Illinois, on the Illinois Central Railroad, February 1926. Later than south Markham Yard on the same yard, May 1926. The Blue Island, Illinois, Indian Harbor Belt and Railroad in August 1926. Hartford, Connecticut, New York, and New Haven, Hartford Railroad, October 1926. The foundation consists of a series of ties and hold together with the tie bars, one and one middle and the angle bar, cranking the bar on the other end. Mechanism attached with rigidly angle the bar was supported with three ties, and the rails are held in position with the chairs and are formed with the rail contour, which is all spaces of the rail from the tie. This shows the electric retarder A. You see it on the side of the tracks with the the railways in the center. The shoes are bolted with the shoe beams with the slide back with the fourth of the group. The chairs interlock with the chairs to prevent the lifting. The shoe beams are 3 feet 8 inches with the length of the articulated with the tongue group with arrangement with the pressure transmitted from one beam to the other beam, so that the fixing of the assembly to compensate the variation in the thickness for the spacing of the wheels. The pressure between the shoe and the wheel is provided with the springs, and which are backed up with the lug on the cross member of the girder, with the turn of the operator held in position with the T-crank driving with the longitude operating bar. Eventually, the mechanism of the spring is kept by the spring rod with the plane with the shoe beam at one, and which is slides with the bearing in the girder or lug. An adjustment with the initial spring pressure provided with the adjusting nuts on the spring rod with the position of the shoe obtained with the adjusting nuts of the spring rod, which shift the beam to relationship of the lug of the girder. The guides keep the girders in line with the outer and center of the tie bars. The two pairs of the girders are assembled in the space between the ties, one pair being connected to the end of the center and by a link, and the two one-sided T-crank and another pair to the other side. Movement of the T-crank provides push on one pair of the girders and a pull of the other pair, with as noted in Figure 13. One pair of the girders is connected through the medium of the spring and the shoe beams on the side of the rail nearest to the mechanism. Other pair of the shoe beams are side of the rail furthest from the mechanism, since the spacing of the hole between the pivot for the T-crank and the pin connection pin connection to the crank of the girders in the same the pair of girders, and movement of the crank provides equal movement as between the inside and the outside shoes from the rail. A large lever pivoted with the crank and angle bar with a link between the lever and the lug operating the bars, provided with the connection to the mechanism throw rod, later being moved out and into the mechanism because of the connection and point eccentric for the axis for the large gear. The gear is driven by a motor gearing through an angular movement with less than 180 degrees. The motor is equipped with a magnetic brake, which is released with the current flowing through the motor and applied with the spring pressure otherwise. The operation consists of the running of the motor without until the proper position of the shoes is obtained with the cutting off the power of the motor, and that automatically means the limit of the switch and the master control, at which the time of the brake is applied with the holding of the operating bar of the T-crank girder for the fixed position. Wheel passes through the retarder, and the shoe beams as pressed away from the rail by the wheel, since the wheel is thicker and the space between the shoe and the thrust of the springs compressed with the provided with the pressure necessary for retardation. Any charge for the spacing of the shoes provided with the variation of the pressure pressure against the wheel. Therefore, the variation of the degree of the retarder may be used with wholly length, may be closed and open at the way until the operator is sure or secure more or less the retardation of the usual practice is closed with the retarder before the car enters, then opens when the car's speed is corrected. The two or more retarders may be assembled end to end, joined together at the point at which the shoe beams articulate with the forming of the one long retarding surface operated with two or more individual mechanisms which are operated with the separate control levers as so far as to secure various degrees of the retardation of each of the units independent with the other units. As adjustment is provided with the throw rod compensated with the wear and shoe bearing. Occasionally it is necessary adjusting the position of the shoes obtaining the proper alignment, and this is done individually at the spring rod. The retarder is usually the length of the varying the 14 feet 8 inches by the 40 inches, the multiple of the 3 feet 8 inches. In some cases, they use it to be use only one railway, and where necessary to locate an opposite with the frog wheel switch. Our electro-pneumatic retarder, the Markham type. The type of the retarder, the figure 14, the first installed with the northbound Markham Railroad, Illinois Central Railroad, March 1926, the South Yard, Gibson, Indiana, with the Indiana Harbor Belt Railroad, in August 1926. The retarder is redefined with a refined design of the retarders of the North Yard of the Gibson, Indiana, and on the Indian Harbor, the railroad. The operating mechanism and the control device was entirely new design. Figure 15 with the diagrammatic sketch of the arrangement of Markham type of the retarder with the air admitted with its backing, the piston with the cylinder with the piston, and the piston rod moving outward toward the left, the various levers moving the direction shown by the arrows, bringing the brake shoe there to closed position at the car wheel enters the retarder spring shown in figure 14, takes the initial shock and compensates for the variation in wheel thickness, spacing, the axle retardation become effective with the compressed air into the cylinder, resting of the reverse action of the levers caused by the car wheel spreading with the position of the brake shoes. 40 degrees of the retardation is obtained with the varying of the pressure of the car, the cylinder, and the varying of the resistance of the reverse action. The linkage of the two open retarders is omitted with the reverse side of the piston exhausted with the operating side. There are just two positions of the brake shoes closed and open. The entire structure is mounted on ties. Figure 14 shows the electro-pneumatic retarder of the Markham type, and this also shows the dynamic sketch of the Markham type retarder, the stop anchor rod, the stop arm, the 12.5-inch cylinder, and noted with all the ports shaped and remaining the immovable and the shoe carrying beams. Alright, your electro-pneumatic retarder, the Boston type, the reconstructed from the Mystique Junction Yard of the Boston, Massachusetts, the Boston and Maine Railroad, less space available than necessitated. The design of the starter within more of the powerful retarder with the Markham type, the Boston type, the shown in figure 16, was installed with the separate number in 1927 with the Mystique Junction Yard, subsequently Allentown, Pennsylvania, on the Central Railroad of New Jersey, and the Portsmouth, Ohio, and the Norfolk Western Railway. The Boston type of the retarder is similar to the Markham type, but they're used with the springs to take care of the variation of thickness and the spacing of the axle, the first shock of the entrance for the car, and the use of the air cushion to provide the various degrees of the retardation and linkage from the operation of the cylinder to the cranks, and is very similar to the remainder of the linkages. However, they're quite different. The outer ends of the spring are fixed, but the inner end of the spring is fastened with the brake beams which carry the brake shoes. The brake beams are moved by the driving of the bar located beneath them and parallel to the rail. The close the retarded air that is emitted with the operating cylinder and causing the piston and rod to move. This figure 16 shows the electro-pneumatic retarded Boston type. To rod to move out of the linkage, then move the driving bar to direction opposite of the direction traffic resulting from each of the brake beam due to the fixed pivot with the springs and move toward the rail on both an arc and rather than right angles. Electrical retarder type B, the first type of the type B retarder, figure 17, was installed in December 1927 at the Mechanicalville, New York, the Boston Maine Railroad, and later in the Selbrick near Albany, New York, DeWitt near Syracuse, New York, and Gardenville. Alright, this shows the electric retarder type B with the rail on the side for your hump yards. Near Buffalo, New York, on the New York Central, the Lancaster, Fort Worth, Texas, the Texas Pacific Railway, Coxton near Pittstown, Pennsylvania, Oak Island, Newark, New Jersey, Lehigh Valley Railroad, the Provision Challenge, Illinois, the Challenge, Chicago Northwestern Railroad, Northern Avenue, the Providence Rhode Island, New York, New Haven, Hartford Railroad, West Detroit, Michigan, Michigan Detroit Railroad, Toledo and Stanley, on the Ohio Century Lambert Point of the Valley, and of the Northwestern Railway, Huron, Ohio Wheeling Lake Erie Railway, the Courtesy Case, Kentucky, Louisville, Nashville Railroad, EB and the westbound, EB, eastbound, westbound, Willard, Lorain, Ohio, and Baltimore, Ohio Railroad. Mechanicville Yard was among the first yards to be built with the track arranged with a group of 6 or within one group of the retards serving each of the group of the tracks. The track space available for the retards was much less than the former yards, but necessitated the design of the retardar, which had about twice as capacity with the retardation of the Type A. The foundation of Type B with the retarder consists of the 8 section of the steel crossing located 5 to 6 feet, 5 foot 6 inches centers with every third tie spacing on the 9-inch by the 12-inch wood ties on each edge. These steel ties became transmit all the force necessary to oppose the force set up for the crossbars. This, differing from the type of the retarder, were opposing the force as were carried in the girders. The type of the space maintained with the two tie bars located one along each rail, but one on the side nearest of the mechanism. The chairs, which support the guide of the shoe beams, are bolted in the steel tie. As the rails are supported with the steel ties of the tie plates or with the wood ties and are held in place with the rail clips. The crossbars are located between the steel tie and the nearest adjacent wood tie, with supported with the wings projecting with the chairs from the tie plates to the adjacent wood tie. Fixed levers are supported in the brackets bolted rigidly to the tie bars, whereas the floating levers are supported with the brackets bolted rigidly to the crossbars. The spring is suspended between the two lower ends of the fixed and the floating levers and contact the levers when the modified knife edge bearing the upper end of the levers contact the shoe beam at the high point as high as the point as possible. Considering clearance, this point is very near opposite the point where the wheels contact the shoe. They're provided with a near straight line transmission for force, minimizing the pressure between the shoe and the beam chair. The crossbars connected with the L-type crank, which is pivoted on the pin projection through the crank of the bar with the angle of the bar, which is bolted with rigidly in the steel tie as well as the wood tie. The operating bar is the support with the connection of the outer end of the L-type. The cranks driven through the medium or lever, which has one end of the pivot with the crank of the bar and angled bar, other than the connected with the tuning adjustment. The rod with the toggle crank. The toggle crank is driven with the throw rod, which then the same as the type of the A retarder is moved back and forth with the mechanism. Figure 18 is a diagrammatic sketch illustrating the closed and open position of the Type B retarder. The full lines show the open position and the dotted lines show the closed position. It will be noted that in the open position, the pin connecting the throw rod of the driver gear is at the extreme point in the stroke of the toggle crank, as is the gear turns through the rod with the moving toward the toggle crank. With the moving of the toggle crank lever, the operating the wave of the mechanism. This pivots the operating crank with the pull of the crossbar crosswise of the track and toward the mechanism side of the track. A central spring leaf springs not shown attached with the shoe beam that have the bearing of the brackets attached with the tie bar and taking them all to play part of the shoe beam on the fixed lever at the side of the plate pressing against the upper fixed lever, which tends to pivot with the fixed lever and thus transmitting pressure from the lower end of the leverage to the spring then lower end of the floater lever tending to pivot with the floater lever against the stop of which was part of the floating lever bracket. The pressure maintains a fixed angular relation between the floating lever and the crossbar unless the car wheel moves between the shoes and takes up all the motion of the bearings. Alright, the dotted line shows the closed and the open positions, full line, regular dotted lines. Open position, closed position, fixed pivot, crossbar, shoe and movable pivot. The driving gear, the open position and closed position. The figures 18 shows the diagrammatic sketch of the Type B retarder. The lever ratio, both the fixed ratio floating lever is 1 to 1. For the example, the crossbar is moved with 1 inch of the upper end of the floating lever, and the shoe beam with which the contact is moved with 1 inch toward the rail. The spring of the spring seat are moved with the crosswise underneath the rail, which is the pivots for the fixed lever, causing the 1 inch of the movement to the upper end of the move the shoe beam with the fixed lever side of 1 of the inch toward the rail. The crossbar is moved with the direction away from the mechanism. The operation of the parts mentioned is exactly the reverse. Therefore, any of the movement of the crossbar provides with the movement of the shoe beam to the both sides of the rail toward and away from the rail, each being moved at equal distance. A description of Type A retarder: the brake attached with the motor holds the fixed position in all parts except for the two shoe beams. This fixed floating levers and the springs and spring seats, as well as the wheel moved in between the shoes. The shoe beams are moved back against the upper ends of the lever, thus forcing the lower ends through together, compressing the large spring. Consequently, the pressure resulting on each side of the wheel are equal, since one of the springs is responsible for both of its pressure. The Type B retarder is positioned with a definite distance between the shoes and is secured with the variation of the retardation. For example, the maximum retardation is obtained within 3/7/8 of an inch spacing of the shoes without the wheel between the shoes. The minimum retardation is attained with a spacing of 5 inches between the shoes. Since the wheel thickness is approximately 5.5 inches, this is provided with the compression of the spring 1.58 of an inch of the minimum retardation, approximately 1/2 inch of the minimum retardation. Figure 19, simplified sketch representing the parts of the adjacent with the wheel, and the figure 18 that illustrates the actual parts represented in figure 19. These the hand in figure 19 represents the mechanism of the parts holding the crossbar in fixed position. The principle figure 19 shows the principle of operation Type B retarder. The fixed pivot going into the A and B and through the A and D, C and D spring. It will be seen that with a while between the shoes E and B, with the pressure with the spring of C with the transmitted through the levers of the wheel through shoes A and B. An additional pull with the crossbar will tend with the move of the crossbar at the further compression of the spring C, with the increasing of the pressure applied to the wheel. The decreasing the pull of the crossbar will permit it to move, and the lessening of the spring pressure will reduce the pressure applied between the shoes and the wheels. The shoes are L-shaped and attached with the shoe beams means of the 5 bolts. The outside of the shoes are made so that the top of the 2 inches above the top of the rail, whereas the inside of the shoe height of the 2.5 inches above the top of the rail. Outside shoes are made with the seal and especially treated and provided with long wear as they contact the roughest and greasiest side of the wheel. The inside of the shoes are made with the softer steel, and as inside of the wheel generally is clean, fairly smooth. The extra height of the shoe above the top of the rail provides with the extra to retardation. The combination of the high inside with the low outside shoe assists the preventing derailment, since the wheel is lifted and the face of the wheel rides the outside of the shoe, the guided with the inside of the shoe due to the extra height until the wheel reaches the edge of the retarder. Each end of the retarder then drops on the rail. As the face of the shoe wears, it is necessary to move them toward the rail. It's provided with the required spacing adjusting made with the moving of the trunnion outward to the adjusting rod, the being sufficient with all shoes in the retarder. Excessive wear in the bearings is taken up with applying the horseshoe shape of the shim to the interlocking which each of the other between the spring and the seats, moving the lower ends of the lower parts, moving upper ends of the levers and the shoe beam toward the rail. Additional adjustment facilities are provided within the shoe beam at the point of where the lever contacts the beam, where the shims are placed between the wearing block and the main part of the shoe beam, as so the shift between beam toward the rail. All adjustment facilities have taken together and compensated for a large amount of the wearing of the bearings. A large number of the bolts retarded can be tightened without the removal of the parts. However, some of them cannot be reached without removing the bolt by the shoe beams. The shoe beams are opened to remove the position with the changing of the connection between the adjusting rod and the toggle crank, so that it will be connected to the fourth hole of the toggle crank, which is very close with the connection at the throw rod. Then operating the mechanism to reduce an opening between the shoes wider than the normal, and a point where the beams can be lifted vertically with the retarder. After the shoe beams are moved, all parts of the retarder are easily reached, and the maintenance purpose. The pressure lubricating system is used throughout the pin type bearings. Most of the pins being drilled through the center and outward. Each of the bearings transmitting the grease. Oil is used to lubricate all the sliding surfaces. It will be noted that the toggle crank is supported by the angle bar of the crank bar, which is the pivot outside of the path of the travel. The operating of the bar, the design of the crank is a position given with the additional mechanical advantage to permit the use of the same mechanism used on Type A retarder mounted. Change at the beginning being made with the adjustment of the mechanical mechanism controller to secure the proper shoe spacing with various degrees of the retardation. The mechanism in figure 20 consists of the train, especially heat-treated gears, the large gear being one of which the throw of the rod is connected with the pin reference to 14, being used in surplus. The horizontal shaft carrying the bevel pin meshed with the bevel gear, and the rolls of the bearing in which where the other shaft, the running of the bronze bearing, lower half of the gears is filled with the splash lubricant in the lower bearing. Figure 20 shows the mechanism Type A and B electrical retarders. In the gear teeth of the up at the bearings lubricated with the pressure, such as the mechanism controlled with the reference figure 1320, driven with the bevel gears, spinning gears, with a large gear shaft as shown in figure 21. Consists of the camshaft upon the 5 cams are assembled. The cams are contact with the idle finger, which in the contract contacts are linked. The operation function of the mechanism control the contacts will be explained later. Figure 21 shows the master controls for the Type A and B mechanism. A 5 horsepower, 230 volt compound wound crane type of the motor is assembled in the main housing connecting the mechanism means of the abort universal coupling. The brake is the disc type permanently attached to the motor. The control circle of the retarder with the shown in figure 2 with the 5 wires are used the retarded lever and the mechanism control of the retarder. This shows the nomenclature for a forward contact control R for the reversal, M for the motor and armature lead, A, Z, SI for the series field lead, and shunts, F1, lead, L for line contactors, T for time relay, O for the control wire over the open position of the retarder, and then 1, 2, 3, 4 for the first degree of for each degree of the retardation, and TR for the thermal railway, located in the tower retarder level with the positive and lever and openings 1 through 4. And this shows the mechanical controller, the motor, and the contactors circuit board. Mechanism 1 being connected with the center of the contact, E for the group of the contacts, 2 contact wires, 1 for the closing, 1 for the opening, are connected with the outside contact stem with the mechanism controlled with the contactor panel, which is located in the sheet sealed with the housing near the retarder. When the controller level is moved to any one of the 5 positions, current flows with the corresponding control wire with the mechanism control through the contact, the forward and the reverse, depending upon the close over the wire with the F and R over the F and R contact. The F is energized with the front contact is closed with the line contactor is energized since there's series of either one of the contactor depending upon which energizes complete the operating circuit. And operating with the current flows with the positive local bias wire through the knife switch leading the element thermal relay through the front of the contact, and contactor F through the armature with the communicating field over the motor through the back of the contact for the contactor R through the series of the field motor the brake coil through the contactor of the line contact with the negative side of the line for an open retarded with the contactor R with the energized with the current flows almost at the same path already described, except for that it is through the armature in the reverse direction through the cause of the reversal of a motor. As the mechanism is moved and the cam of the mechanism control are rotated with a definite point. Each of the cams dwell with each time of the central figure is moved with the free both in contacts F and R with the de-energizing, which contact may be energized with cutting off the current with the motor with applying with the brake with the de-energized both the F and R shorts of the armature through the 1.9 ohm resistor with the combination of the residue remaining of the field cores right over the dynamic braking, assisting the braking and stopping the motor after passing through the dwelling on the cam. One or the other contacts in the mechanism controller are closed, which select the contactor which must be energized to obtain the proper rotation of the motor throughout, regardless of the position in which the control lever is placed. The mechanism flow immediately at the position of the stop position of the shoes, finite space consequently defined Any degree of retardation protective devices are used the first time the relay is limited to the time at which the motor energized with the given moment. The second thermal relay, which opens in the case of the motor, the heat is excessive. The time relay normally is energized through the back of the contacts of the relay F and R, de-energized with either of those relays energized. The timing is obtained with a lag breakdown of flux, 5 to 7 seconds, and timing is obtained. The electropneumatic retarder of the Model 28. The Model 28 retarder figure 23 is designed to make the available retarder even more powerful, more rugged, but more flexible than the Boston type. Complete installation with the were made with the Sharonville yard with the near Cincinnati, Ohio, Cleveland, Cincinnati, Chicago, and St. Louis Railway Cedar Hill yards near New Haven, Connecticut, New York, New Haven, Hartford Railroad, the Pitcairn yard near Pittsburgh Yard, the Pennsylvania Railroad, the Russell, and the Kentucky Yard of the Chesapeake, Ohio, the Potomac Yard near Washington, D.C., the Richmond, Fredericksburg, Potomac Railroad, the Perrin, Ohio Yard, the Erie Railroad, the Galesburg Yard, Galesburg, Illinois Yard, the Chicago, Burlington, Quincy Yard. Additional installations were made with the Gibson Yard and the Indian Harbor Railroad, Port Ohio Yard with the Norfolk Western, Allentown, Pennsylvania Yard, Central Railroad in New Jersey, and the Mystic Junction Yards on both Boston and Maine Railroad. Alright, figure 23 shows the electropneumatic retarder in Model 28. Model 28 may be sold to be divided into three parts of the brake cylinder, some of the driving links, and the radius of the rod brake beam assembly. The brake cylinder used for the operating of the Model 28 retarder is anchored in the bearing plate so much that in such a manner that a reaction through the bearing plate and the driving of the crank through forms the closed section. The closed system of the force of the cylinder has two pistons. The main auxiliary, the piston rod of the brake cylinder, is connected with the floating toggle lever means for the position connecting link of the one side of the floating toggle lever drive the inside of the brake shoe between beams through the associated the connection other side of the toggle drive to the outside brake shoe the beams together with a similar part connecting the floating of the toggle with the center of the unit with the spring of the mechanism exerts the resistance of maintaining the floating toggle lever in the position where the retarder is either being open over the closed or the brake shoe beam taking the proper position of relation with the rail. Figure 24 shows the linkage of the open position light control lever in which the first and second and third position of the toggle lever moved until they make the slight angle with the toggle connection rod as illustrated in figure 25. The angle is greater than enough to permit the reaction caused by a car entering the retarder to send the driver the piston back. These items, thus in three positions, the general principle early design electropneumatic retarders followed with the use of the springs, initial shock, and wheel variation compensation and air cushion for the retardation. This shows the all working parts of the being protected, the inside shoe with adjustment and the outside shoe adjustment, and the Zerk fittings throughout. Figure 24 shows the linking model 24 in the open position. With the control lever in the fourth position, however, the toggle lever that forms nearly the straight line with the outer drive with the links of the shown in figure 26 through the does not come into the dead center position. In the position will be closed enough with the dead center so that the air pressure will be applied with regulated with the control circle. There will be no movement of the piston during the retardation. Therefore, the force position of the retardation is obtained, but the deflection of the springs in the air is used only to hold the toggle in place. The locomotive is used the comparatively wide with driving wheels, which should move through the closed retard of the generally movement of the brake shoes, and consequently greater deflection of the springs causing the toggle to break, and parts of it take the position shown in figure 25. Figure 25 shows the linking model of the 28 retarded first and second and third position. Figure 26 shows the linking model of the 28 retarded in fourth position. Referring to figure 27, the noting of the center of the unit is C, consisting of the double-acting spring housing intending to keep the brake shoes always the proper relationship to the rails opposite with the movement of the lever. E, the initial compression adjustment with the center spring is sufficient to overcome any of the ordinary friction that would train and to prevent the shoes from closing when they opening the prior properly relating to the rail or with relation to the rail. When centering enters the retarder with the reaction of the two inside sets of the brake shoe beams that oppose with the reaction of the two outside sets beams the construction equalized with the pressure brake shoes beams at the end of the same time provided with the centering force which remains in the center line with the trucks over the center of the track. The condition of the balance equalization holds because of the floating toggle lever is free to move relatively speaking lengthwise in a retarder with who when too great of the retardation pressure was applied with light cars with the wheels may be forced from between the brake shoes. In such case the wheels This shows the driving bars, the field point, the brake beams, the toggle into close. This is the diagrammatic sketch for the Model 28 retarder. While riding the brake shoes at the end of the retarder, the drawback of the railway, the guide rails which are built into the end of the railroad and retarder ensure that the wheels always drop back into the rail. The turnbuckles on the toggle connecting the rods provide with adjustment compensating the normal brake shoe. The wear with responsible wear with the part of the driving linkage adjustment provided with the outside of the shoes and other inside shoe is necessary to adjust the particular with the shoes inside and independent with the others and compensate with the wearing of the provided driving linkage that can be done with the bend and the self-locking radius adjustment nut. After referring to figure 27, note that the arms of the outer and lower end driving crankshaft of the construction with the obtuse and acute angles respectively instead of the right angle to provide with linkage and maintain the nearly constant mechanical advantage whether the retarders adjust the new worn shoes or result with the particular practical with the same open dimension being with maintained with various conditions shoe wear without the necessity of changing the piston stroke. The cranks are mounted with the heavy H-beam structure securely riveted together in C figure 23. In detail, with the radius and rod brake beams assembly has been changed with the bottom in the Boston type of the retarders, although the same principle of the radius rod assembly composed with the radius rod shaped within the pin of the brake beam ended with the helical coil ended with the self-locking radius adjustment and the effective length of the radius rod without affecting the spring adjustment with the spring adjustment nut and the trunnion, which is supported with the top of the bottom. The heavy top flange of the brake beam with the heavy top blade with the trunnion bearing plate and assembly particularly covered the protect the radius of the rod of his assembly from the damaged section. Removal of the radius covered the plate with the close of the space between the top of the flange of the brake beam and the top of the plate, the trunnion bearing plate assembled with retarded in the closed position. The plate removed with the space provided with the tamping of the trunnion bearing the plate assembly supported with the brake beams and driving the bars of the trunnion end with the radius rods assembly into the composed with the two pairs of the heavier pairs and one pair of the side of the given rail. All four plates securely tied together in the proper position in the casting steel yoke for the arrangement of the radius rods in relation between the brake of the beam with the driving allows the inner edge of both the outside and the inside of the brake beams which carry the brake shoes that rise about an inch. The brake shoes engaged with the car wheels are provided with a higher grip inches above the top of the rail. The car wheels are greater the retardation since the shoe the lift only the wheel arranged with the retarder. The usually clearance and limitation exists. The brake beams at each end of the retarder are flared out of the rail to provide a customary wider opening between the shoes and at both ends of the retarders which give the smooth entrance condition. Entire structure is securely fastened and added to the ties and the foundation connections mounted at the brakes with the brake cylinder and electro-pneumatic valve, the means by which the desired control of the retarder is obtained. This control valve with assembly in figure 28 consists of the control valve and the three-step pressure regulator, the single-step pressure regulator, and single circuit controller of the rectifier. The control valve consists of the four electro-pneumatics A, N, R, and X, together with the associated valve and piston. They are similar to the construction described in chapter 18 electro-pneumatic interlockings under the heating switch valve. The three-step of the pressure regulator, figure 28, is used with all type with the electro-pneumatic retarders consistent with essentially with a small pipe to are fastened with the burden tubes, with such as to use with the pressure gauge the various kinds. The pipe is connected with the operating portion of the brake cylinder add to the right of the main piston, so the air pressure of the brake cylinder is always the same as the pipe of the burden tubes. The characteristic of the tubes is that the tendon of the straighten out of the pressure then increase the provided with on the end of the contact of the finger with the conjunction adjustment in contact screws close open in certain current circuits depending on the pressure of the tube. The single step pressure regulator in figure 28 is the same as the three step regulator, except that it only has one tube that connected with the non-operating portion of the brake cylinder to the left of the main piston. The circuit control circuit is similar to those used in electro-pneumatic interlocking machines. Actuated moving of the main piston means a mechanical connection with the floating toggle lever. The rectifier, figure 28, the copper oxide type. This is the simplest electrical check valve that is permitted with the reducing the number of the wires required between the control machine and the retarder. This shows the figure 28, the control valve of the assembly of the Model 28 retarder, the circuit control, the X contact screw, the three-step pressure regulator, the control valve, the rectifier locking screw, adjusting screw, single-step pressure regulator, and then it shows on the side it shows the spare for the fourth pressure, second pressure, and first pressure. Our figure 29 illustrates the control circuit for the Model 28 retarder as shown in the magnets A, N, and R de-energized, but the magnet X energized, and all the closed position is air admitted with the rod side with the main piston, first and second, third position, all the full pressure is admitted with the rod side with the auxiliary position. The auxiliary position is held at the inner end of the stroke in these position. X with the stop at the main position, the limit to travel the fourth position, and the area is vented with the rod side auxiliary piston. With the auxiliary piston is then pushed back at the main piston, but the opening between the brake shoes is in slightly less than fourth position than the others. They also the toggle is almost dead center with the position in fourth position. Air pressure at full pressure is applied with the closing of the retarder until the position comes within within an inch of the end of the travel while moving toward the fourth position between the point of the end of the stroke of the air. The governed by the setting of the pressure regulator in third position. At the full pressure is emitted with the rod side of the main piston with the rod side with the auxiliary piston, and moving the fourth and third position. Air at the full pressure is applied with the rod side auxiliary piston, which moves the piston back to the third position with the main, which the main piston reaches the third position at the contact a contact. Figure 29 shows the control circuit for a Model 28 electro-pneumatic. It shows the control lever, the 1, 2, and 3 X and 1, 4 control circuit. For the auxiliary pistons, the retarder control valves, the air supply, the electromagnetic, the magnets, the pressure regulator contacts, the RX contacts, the R contacts, and the lines. And the circuit controlled by the closed emitting with the air to the flow on full pressure with the rod siding of the main piston, then moving open at the first second position. The pressure regulator is shown with it all the full pressure, then emitted with the 1/3 with the stroke of the air is allowed to expand and maintain above the setting of the contact, the R, until the position is within 6.5 to 9.5 inches of the final position with the contact X is closed for the pressure control with the valve pressure between the setting of the X and R when it is maintained with the opening of the retarder. Air on the rod side of the main piston is vented and air emitted through the valve A with the rod side of the auxiliary piston with the space between the two pistons. Single step pressure regulator control valves A with the opening of the retarder that regulates the pressure or used when the retarder has almost reached its full open position. The magnet X remains energized, although the magnets A and N are de-energized. The air between the two pistons is then retained with the retarder removed with the full open position expansive power of the air. Assuming that the retarder is open to figure 29, all the magnets except for the magnet X de-energized with air vented. The principle of the circuit may be illustrated following through the operating of the one circuit in the second position. The control lever is moved into the second position of the positive over the wire T12 through the coil of the magnet R over the wire P to the contact of the 2PF of the circuit controller over the 2P wire when the rectifier D over the wire 1P and 2P through the contact over the lever closed with the second position over the end 12 negative battery magnet R is energized with the air full of the pressure with the flows of the rod side of the main piston starting the retarder toward the closing position. As soon as the piston has moved enough to close the circuit contractor, the contact of the ZP with the circuit of the Z is completed with the energizing of the magnet and emitting air full pressure to the rod side auxiliary piston moving into the inner position end of the travel. When the piston is moved to within 9 inches of the final position, contact the 2PF, the circuit control breakers. Circuit control is open to the de-energized magnet R, thereby cutting off the air to the full pressure, removing the shunt with the contact 2P with the pressure regulator. The piston continues to move under the expansive power with the air already emitted until the pressure drops to the valve, which on the contact R with the pressure regulator is adjusted. Close contact 2P, but the pressure regulator is set with the 28 pounds, so the pressure is maintained within the cylinder. If the pressure rises above 40 pounds because of the movement of the piston of the car goes with the retarder because of the leakage of into the cylinder, contact X of the 2P will be closed in excess of the air vented with the valve X. But other circuits will produce the approximately same operation of the magnet valve with the different slightly arranged with the rectifier contacts. The operating of these circuits of valve with match much of the same manner. The Model 28 retarder is equipped throughout the pressure grease. Fittings are manufactured in two lengths, 38 feet by 6 inches and 31 feet by 2 inches. Electro-pneumatic retarder Model 31. Model 31 retarder is shown in Figure 30 was designed to make the available retarder would be the least powerful of the Model 28. This could utilize be the length required when they could economically use either the single or double rail retarder would be required at the tangent and either track installation. Alright, as in April 1st, 1946, the following yards were completely equipped with the Model 31 yard. The Hampton, Scranton, Pennsylvania, on Delaware, Lackawanna, the Western Railroad, eastbound and westbound, and Nola, Pennsylvania yard, or the Pennsylvania Railroad, eastbound and westbound, clearing in Illinois yard with the Baltimore Railway, Chicago, Illinois, Roanoke Valley yard, the Portsmouth, Ohio, timing freight yard with the yard of the Norfolk, and the Western Railway westbound Gainsborough yard, and the eastbound Lincoln and the Nebraska yard, on the Chicago, Burlington, Quincy Railroad, southbound on the Richmond, Fredericksburg, Potomac Railroad. Installation of the Model 31 retarder was also made in connection with the electropneumatic retarder Model 31. The coal car with the dumper facilities in Pennsylvania Railroad at Sandusky, Ohio, under the construction of April 1st, 1946, out of the yards of Milk Wilco, West Virginia, United States Coal Coke Company with westbound Pitcairn and Pennsylvania Yard, on the Pennsylvania Railroad bound eastbound Cumberland Yard, and on the Baltimore, Ohio Railroad, which yards were equipped with Model 31 yards. In addition, with the Model 131 yards, retarders have been installed to replace the older types of retarders following the yards of the northbound Markham, Illinois yards, on the Illinois Central Yard with the eastbound Allentown Yard, on Central Railroad, New Jersey westbound Portsmouth, Ohio Coal Yard, Norfolk Western Yard, westbound Cherryville, Ohio Yard, Cleveland, Cincinnati, Chicago, St. Louis Yard, eastbound, westbound, Cedar Hill. New Haven, Connecticut yards for the New York, New Haven, Hartford Railroad, eastbound the Pitcairn, Pennsylvania Yard, and the Pennsylvania Railroad, westbound Russell, the Kentucky Yard, on the Chesapeake, Ohio Railway, northbound Potomac, the Alexandria, Virginia Yard, with Richmond, with the Fredericksburg, Potomac Railroad, westbound Marion, Ohio Railroad, Erie Railroad, and eastbound Galesburg, Illinois Yard, with the Chicago, Burlington, Quincy Railroad. The model retarder is built on the unit with the section principal. Each of the section between 6 to 3 feet 3 inches is composed with a shear simple with a self-contained interchangeable cylinder. You space either by the third tie and a double rail retarder on one side of each of the track, which for the brake beams they are associated with the brake shoes are attached. The air in the cylinder unit is supplied through the pipe with low connection to one of the electrical pneumatic control valve. The retarder moves to the one position with the combination of the gravity and spring pressure. No springs required for either to obtain the retardation take off the initial shock with the retarder adjustment itself. The various car wheel thicknesses, the spacing of the axle with the pressure exerted with the wheels in uniform equalized. Sensor of the empty of the cars to be raised with the greater the retardation pressure applied with the unusual small. Over the guide rails are provided with the prevent derail on any of the cars which may be raised. The cylinder unit with the figure 31 consists essentially with a pneumatic cylinder, the pair with levers which connected together, which separate the units for the swing of the round with a common pin called with the lever falcon pin. This pin supported with each end of the rail supported the bearings in which all supporting the rails are fastened on the tie. The levers are centered with the relation with the rails, meaning the spring bolt assembly which is mounted in the house and formed in the lower level. Figure 31 shows the cross section of the Model 31 retarder. When the air is admitted with the cylinder, the lever moves back to the brake ring, shows the engagement with the car wheels in a manner similar to the action crack of the air is vented with the cylinder. The upper the lever which carries the outside of the brake beam moves to the out position. The gravity becomes the rest for the upper level spring nuts hit the boss and provided with the rail support. Figure 31, the lower lever which carries the inside of the brake beam moves into the open position through the combined effect with the gravity lower level return spring and comes when the position is pushed away with all the way back cylinder, the upper stop of the ring of the center spring of the arrangement. So the design with the retarder either with the closed or open position of the lever cylinder, then there is associated with the brake beam shoes, then it can swing until the level fulcrum amount with the equivalent point with the last 1/2 inch travel to the brake shoe either side of the position shown with the retarder in the closed position permits the brake shoe to adjust themselves to various spacing of the car wheels. The axle of the retarder in those opening position permits the brake shoe to adjust themselves, and the passages of the locomotives having usually wide driving wheels. The control circuit with a diagrammatic view of the control valve pressure regulator shown in figure 32. Operation of the pressure regulator with a similar described Model 28 retarder, and the fourth step of the retardation of the air pressure as follows. Our figure 32 shows the control circuit with the Model 31 electropneumatic retarder. The notes the style of the RM21 rectifier and the 16 MFD condenser. Alright, one shows the diagram for the rectifier, the retarder control, the terminal board, the pressure contacts, the battery, the 130-volt control magnets, and also the exhaust, the petcock, air supply, and to the other cylinders. Alright, your switch layouts. In retarded yards, necessity of the very compact layouts are held with occasional lap switches. Figure 33 shows the plan for the switch layout of the lap switch. Figure 33 shows the lap switch layout. Figure 34 shows the location of the insulated joints with the track circuit with a single lap of the layouts, but will be noted with the lap switch layout with the separated the track that are employed on the first, second, and circuit protecting the first switch, and the second and third circuit protecting the last switch. It will be noted that the track circuits are specified on at least 55 feet over the overall length and have the length of the headed with the points and sufficient permanent complete operation for the switch machine and the time required for the car moves its distance. Figure 34 shows the location of insulated joints on the track circuit with the switch of the hump yards retarded with the single switch and the lap switch. Alright, your general principles. The switch's quicken movements require not more than 1 second to operate. The switchman does not need the reversible mid-stroke since the time is available is not sufficient to permit making such an operation. Switch may or may not protected by track circuit depending upon the type of the layout and local conditions. Indicate with the control machine the advantage, but not necessary as possible to trail with the switch points without the damage of the point of the switch machine. The target on the light provided with each of the power operated switch indicated with the position of the points. Alright, and then I'm going to cut this tape. It's 1 hour long.